So till now we have just made a section of yesterday's one. So now we're going to work on the next one, which is our understanding the the pipe diameters. So the reason why I'm telling you this is for you to calculate the hydraulic calculations or the loss that's incurred in the pipe, your exact internal diameter is required. That's the reason. So whenever you have a pipe for whatever diameter it is, if you take this as a cross section of a pipe, this is your internal diameter, your
Yes.
ID, and obviously this is your wall thickness,
Mhm.
right? So this becomes WT, wall thickness, and this becomes your OD. OD. So your OD is always equal to ID plus 2 times the wall thickness. ID plus wall thickness will become my ID, right? Sorry,
Mhm.
OD, outer diameter. Outer diameter is always equal to internal diameter plus 2 times the wall thickness, isn't it?
Yes, sir.
So for this, you can obviously download the brochures of manufacturers like Jindal Steel or anyone. You can download the brochures, they'll be providing it. Or we have got certain standards using which also you can refer Schedule 40 pipes and you'll be able to do it. Standard or Schedule 40 pipe is the pipes that we always use in our firefighting system. Am I clear?
Okay,
Yeah,
sir.
Chaitanya, yeah.
Okay. But above 200 IA, again, you've got this heavy pipes, we use it. So I guess I don't have it, but I'll try to get one brochure because in my office laptop, I'll have all the brochures. Because generally for TDS approval, vendors will be sharing me. So yeah, just a sec. I'll try to get it online. Let's see. Zindal Hisar MS pipes. As per the brochure. Let's see. In this, we might get. Yeah, in this, we've got it directly. So I'll just download it a bit. I'll download this game. Yeah. This is Zindal Hisar, Zindal Hisar. So, pipe brochure. It's not working. Or you have to print. Okay. Oh, it's also there. Yes, just a second. Let's see. You can go to the brochure. Just a second. It's stuck.
Chaitanya, it's okay, Chaitanya. You continue the calculation. This, anyways, we'll also try to get it from anybody
Yeah,
from
yeah, no,
this.
no. No, now for us to calculate, we have to go through the process, right? That's the reason. We require this data. That's the reason I use. Yeah, so this galvanized pipe is black pipes and glass pipes is what we use it anyway. Okay, so for this, if you see it, just a sec, yeah, and black pipes for glass and you can see this particular one. Are you able to see the screen?
Yes, yes, yes.
Okay. So now we have to refer to this particular one. So you've got 8, 10, 15, 20, 25, 30, 40, 50, 65, 80, 100, 125, 150 are the standards. It's 175. I mean, the stock is generally lesser, but you can get it actually 200, 250, 300, 350 like that will have it. So in this case, you will always go for this heavy is what we use it in HVAC or your firefighting system application. Okay, which is equivalent to our schedule 40 pipes.
Okay.
Okay, so in this case, if you take your 25 dia, your heavy pipe, if you take it, what is the that you have got it? 4 and your outer diameter minimum is 33.3 and 34.2. So these are the tolerances. See, when you manufacture, obviously in decimals, you'll not have it. So you've got 33.3 as your minimum and 34.2 as your maximum diameter.
Can
You
you
can see the
zoom into
cursor
that
properly.
diameter, Chaitanya?
Oh, okay, sure. Yeah,
Okay,
25 heavy. 33.3 is your maximum diameter, minimum diameter, maximum diameter is 34.2. Both are your outer diameters. That's a tolerance that the manufacturer will provide you.
Okay.
And the wall thickness is 4 Yeah.
Yeah.
So shall we mark the internal diameter to the reeds?
Yeah.
I'll write the internal diameter here. So 25 is your nominal diameter. 25 diameter is a representative diameter. It's neither your inner nor your outer diameter. So anyway, let's take the calculations once again. Yeah, this is not required at this point of time. Yeah. Okay. So here, what is the inner diameter? Is that your nominal diameter is 25 25. Your OD and ID, sorry, wall thickness, so that I'll get my internal diameter. So OD is what is the OD we have got it from the brochure? 25 alva. So that is 33.3, 34.2. So 33.3 plus 34.2 is equal to 33.4 plus 33.2 divided by 2. So that will get an average value. That's the reason. Okay, so 33.3, sorry, 33.4, 30, obviously it's 33 point. Hey, this is 34.2 alva.
34.2, 33.3.
Yeah, so it's 33.8 is an average value that you have it. And what is the wall thickness you've got it? That's 4 alva, for heavy.
Yes.
So it is 4 So internal diameter is 20, your outer diameter minus 2 into wall thickness. So 25.8 is the exact internal diameter that is available. Am I clear?
Yeah.
Okay. So like this, we have to calculate for different diameters when and when required, and then we have to work on the hydraulic calculations. Okay. So this internal diameter is 25.8. So let's we need not note it here. Anyway, in Excel sheet will be the record of it. So don't worry. Now what we have to do, we have to calculate what is the pressure loss, what is the this is Excel dimension. Just set the modify the text size and yeah, leaders are also there 150 right. Now we have to mark what is the pressure at this location. What is the minimum pressure that I require so that we will get the minimum flow rate. Understood? So if I want to really calculate, this is some icon that have come.
Chaitanya, what is the pressure at the remote point of sprinkler should be?
That's what we are gonna go to. Someone try to join. Just a sec. Okay, someone is there. Just a sec, please. Someone is trying to join again. I guess some person have left. Okay, admit. Just to give in Prem have rejoined again through his laptop, I guess. Yeah, Prem was joined. Hello.
Prem, are you there? Chetan, can you call him?
Yes, sir. Yes, sir. Yes, sir.
Yeah, have joined. Yeah. Yeah, Madhu, you were asking me something, Charlie.
What should be the minimum pressure at any given point of a sprinkler in a building?
Right. So minimum pressure is minimum pressure will take around like 12 1.2 kgs, I guess 12 psi is what we take it. Hello.
Yeah, go ahead.
The minimum pressure we have to consider is 12 psi, but we have to calculate the flow rate requirement also. From then we will calculate it. Understood?
Okay.
So whichever is highest, that is what we have to take. Okay?
Okay.
12 psi. Yeah, 12 is the minimum pressure that we require it. But again, that depends again on the type of sprinkler. If it is ESFR sprinkler, that's we use it for racks and all, then it will be a bit on the higher. It could be even be like 3.5 kgs also it could be. That depends on the type of sprinklers that we are setting. But for general sprinkler, but regular sprinklers like 12 PS is what that's the minimum pressure that we maintain anywhere. Yeah.
Okay.
So here, if we take this
Sir,
particular, yes, you tell me.
sir, I lost my network. So please, can you go through once the upper part?
Actually,
I
we didn't
lost
have
it
much
all.
discussion. We just had like, what is the inner diameter, what is the outer diameter? I mean, if for any given pipe, how do we calculate the inner diameter? So that is nothing but your in the same in your plumbing, however you do for your hydraulic calculations, if something is required, a similar way we do it here as well. So your nominal diameter is 25 if we take it. The outer diameter from the brochure that we get it here is 33.8 again. Just I can show you. So for 25 heavy, 33.3 to 34.2. So we'll take an average of these two elements. We'll get a average outer diameter, and then we get the wall thickness. So outer diameter minus 2 times the wall thickness is nothing but your inner diameter. Understood?
Okay.
So that is what we have discussion shortly. Nothing else. And I made a section previously for that. Okay. So now we're gonna work like this is a section I've made it for the sprinkler. Okay, assuming you're cutting the section something like this. Yeah. So now we have to calculate what is the flow rate that is required. So if you remember, as per our charts, right? So we've got our chart, Salva. So from this chart, what is the density that we had to consider? If I'm not wrong, the value that we have considered is 2,500 square feet, Alva. Just a sec, let me just be sure of that. So this
4,000.
is the area, right? Just a sec. So this is the area of 1, 2, 3, 4, 5, 6. So that's around 278 square meters. So 278 square meters under equal to 78 into 10.76. Yeah, 3,000 square feet approx. You agree? Hello.
Yes, sir.
Yeah. So this value is 3,000 square feet approximately. We have selected it. So this value, if I'm not wrong, we have selected it. It's 3,000
Yes.
SFT.
Mm.
So this, if we drop it down, this is 0.11, 0.12 density, if you guys remember.
Mm.
Right. So the density is 0.12. So what we have to do is we have to calculate what is the area of protection, area. So selected point is how much? Selected point, I have to worry about our density and this one. So density is how much?
0.12.
0.01.
0.12 GPM per feet square. And I have to worry about each coverage area, how much is it? So now I can directly draw I have the rectangle and I have the number of sprinklers. So I can divide the rectangle by number of sprinklers. I'll get each sprinkler how much area it will cover or not.
Yeah.
So I'll pick a list option. So that is around 1, 2, 3, 4, 5, 6, 278.81. That's around 3000 anyway. So density is just an area coverage. Area is 3000 SFT and number of sprinklers. Number of sprinklers, if you take it, that's approximately how much? 1, 2, 3, 4, 5, 6, 8. 8 into 3. Alva? We got 24 number of sprinklers. My voice is repeating somehow. Just check in. Even if you probably might have to go to mute or something.
There is no issue as such.
Okay, I could hear my voice. Now it's better. Previously, I've heard my even now I'm hearing my voice again. That's the reason. See, so now we have to calculate minimum for each sprinkler. What is the thing? So area coverage by each sprinkler. So what is this value we have it here? So is equal to this value divided by this day. So that is 125 SFT is one particular sprinkler. You agree?
Yeah.
Yes.
So what is this units is GPM per SFT.
GPM per square
So now if we take it, so this is the area. So now we have to calculate what is the flow rate, minimum flow rate requirement. Minimum flow is 125 into 1.2 GPM. So minimum 15 gallons per minute is the flow rate that we require for each sprinkler. You agree?
Correct.
So what we have done is simple area coverage by sprinkler into density. So that will give us the flow rate parameter. Then coming to the next element that we have is how do we calculate the pressure that we require. So you guys are aware of formula Q is equal to K root P, right?
Yeah.
So we use the same formula here. Q is equal to K root P. So your K factor of a sprinkler is 5.6 or equivalent is this PSI and all will use this 5.6 anyway. But if we use in kg per centimeter, the units will change. That will be in LPM or something. You'll get it. Okay. So here, if you take this Q value you have to calculate. Q, I already know it is minimum of 50 GPM. So now, don't you think you have to calculate the P value over here?
Yeah.
Q is equal to K root P. Obviously, then P is equal to Q by K square.
Yes. P is equal to Q by K square.
Q by K whole square. So that is 7.17. Sorry, it's not 15 psi. I require 7 psi if I'm not wrong. Minimum pressure that we require. Just a second. I'll just Google and minimum pressure we have it for our IS code as well. Just a second. 7 psi is what I remember. Even after seeing this number, I couldn't recollect it. I'm really sorry. Minimum pressure. So then PSI will take it. That is only for this one. We have it as I told you 10 point. Pressure for various applications in Exceed. Okay, that the minimum pressure for various applications shall be. Just a second. Is there an X here? In sprinkler, when all the sprinkler design area operated shall be as per 10.5.7. 10.5.7 we have to refer. Just a sec. What is this actually? Topic is, okay, this is in rack sprinkler. This Now, this is the pressure actually. If you see, this is a particular pressure, but this is only for ESHRF sprinkler, not for any other sprinklers. Okay. 7 PSI, if I'm not wrong. The number is 7. I remember roughly. That's the reason. So specific pressure, maximum pressure. So, yeah, that is just a second. I'm trying to find that exact figure. That's also 0.5. Sprinklers at a minimum of 0.5 pressure for the exposed load bearing column horizontally. Thank you. A lot of locations it's coming 0.5 bar, but that will be 5 alva. Just a sec. 0.5 bar means. Sorry, quickly that go.
NBC says maximum pressure of 12 bar.
Yeah, that is maximum. This is 0.5. Is 7.2 psi. 7 I told you, remember? In the charge I've clearly given, most of the cases, sprinklers shall be designed to provide a discharge pressure of at least 0.5 bar at each sprinkler when operate altogether. Except ESHRF, generally we take 7 PSI as our value, not 15. 7 is the minimum pressure that we have to maintain. Understood? Hello?
It is given in GIS code, is it? The minimum pressure?
The minimum pressure, yes, you can see it here. I mean, at multiple locations it is provided. To provide sprinkler at minimum of 0.5 bar pressure for the entire exposed load bearing columns, for all, maximum of the applications it is provided.
Minimum 0.5 bar, is it?
Yes.
Okay.
Yeah. That's
Yeah.
around 7 PSI to become anyway.
Okay.
So what is the exact conversion? 7.25 we got it. You will see it here. So here we got 7.17. So minimum we have to maintain 7.2 PSI. Hello.
Yes, sir.
So we have to do recalculation for 7.2. What should be the discharge? So K factor will remain same, but Q is equal to K root P is equal to K into square root of P. Square root of P. So that is 15.02 GPM is what we will have. I mean, around 15 we can get that 0.02. It's fine for us to ignore as of now. So shall we take 15 GPM only? Lucky that we got nearly 7, but at times you might get 5 or 6 means, but still you will maintain it 7.2 and then you will recalculate what is the minimum flow rate that is required. Understood?
Okay. Yeah.
Okay. Now what we have to do is we already got the value of 15 GPM. So at this location, we'll have a flow rate of 15 GPM. For the sprinkler, the minimum flow rate that I require is 15 GPM. Okay, unless you have a very heavy long dropper, you can ignore that small piece. Else, generally, we have to calculate what is the pressure loss across that as well. Okay, but currently, for an example, theoretical problem, we'll ignore that. We will only consider the horizontal distances. Is it fine? Hello.
Yes, 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 Chaitanya.
So now we'll try to calculate what is the anyway, we already know the pressure that we require. So I'll just change the colors for ease. Yeah. So the pressure that we require in this location is 7 PSI.
Yes.
exact value is 7.17, so 7.2, anyway, 7.2 PSA will take it, 7.2 PSA. And this one is 15.002, right? 2 decimals will anyway use it. So 15.02 GPM is what we have to consider it. So these are the values that we've got. Now we have to calculate. So we know the pressure that we require and what is the flow rate. Now we have to calculate the pressure loss across this one and this one, so that we'll get to know the pressure at this location. So I'll rename the names of the sprinklers for ease. This I'll write it as A. This I'll mark it as A. This is B, C, D. That will give different names. So here this is A. This is B. This becomes a C. D, E, C, D, E, F. At this point, I'll mark it. Okay. C, D. So that in Excel sheet, when you refer later, it will be easy for you to understand which part I'm speaking about. F, and this is G. This part I'll make it as point as H. With the branch, I'll mark it as a separate code. I'll give it to it. Okay. Fine. So now there are two A's. Shit. Shift all these things. Just as Excel. Yeah. If G, H, and I. Is it fine? Okay. So now we have to calculate what is the pressure drop. I'll have it across this pipeline. You agree? So if I want to calculate what is the pressure drop between A to B, we have to calculate the basic calculation. So for that, we have to calculate what is the internal diameter, what is outer diameter, each and everything. We have to calculate for this 25 mm dia, which we have done it anyway for 25 mm as a sample. So that particular data is what we are going to use for that. So what is the pressure loss that will be incurred? For that, we have a basic formula that you use it even in your plumbing also, which is your this one for this Heisenberg equation.
Heisenberg's formula. Yeah.
You guys use this formula,
Ah.
especially for forced pumped drain or something. You'll use this
Yes.
formula
Yes.
generally.
Yes. Yes.
Non-gravity type. So same thing we can use it here as well. Okay. So we use the same formula to calculate what is the pressure drop across. I'll just explain you this formula here. So P is PSA per feet of the pipe. What is the pressure loss that will incurred? And if you obviously multiply with the length, then automatically we'll get the total pressure drop. 4.52 into Q power 1.85. Q is flow in GPM divided by C is your frictional loss coefficient and D is your actual internal diameter. So that will basically give you the entire frictional loss per feet of pipe. And then if you multiply it with length, automatically you'll get the total total pressure drop. You agree?
Yes.
So we'll take this formula. Yeah, we'll try to do this. Just a sec. Okay. So I'll just zoom out slightly for ease. Okay. So here I'll write all the things. So P is a pressure drop I'll require. So I'll write it as del P. Okay, delta P. That is nothing but the delta pressure drop that we have it. And then we have got Q value, C value, D value. Q value, C value, and D value. Right. So her diameter also will have it. So diameter is basically your internal diameter. So for me to calculate the internal diameter, don't you think I require your outer diameter and the wall thickness? then I'll get my internal diameter.
Internal
Alva?
diameter. Yes.
And then we'll take the length. Sorry, shall I make it another sheet? Because that is better. Delete. The Q is discharge. So the flow, basically. Flow already. Flow, what is the units? GPM. Right. And then C is basically the constant, Heisenberg constant. Depends on the pipe material. And then you've got your outer diameter. OD is your outer diameter. W, I'm not writing, is it okay? So outer diameter, wall thickness, ID, and then we have got length. So here the units is important. So the diameter is in inches. Okay. So what we'll do is we'll convert this in mm, and then we can I'll write it in mm. Don't you think we can convert into inches later on?
Yes, it can.
It's possible. Yeah.
Obviously. In millimeter, I'll just divide the value by 25.4. I'll get it in inches. Ashte alva. Okay. So now we have to calculate the del P value. So here, what is the flow rate that we have to calculate? So flow rate is how much? What is GPM?
12,
15 GPM, alva?
15
15.02
GPM.
GPM.
Yeah.
15 points. Okay, I'll write from where to where also. That's it's a section of the pipe. So this is at A or A to B. Sorry, A to B. A to B. The del P is so 15.02 right? GPM. Constant is Heisenberg equation. If it's all galvanized steel, the value will be galvanized steel or any black steel also, the value will be 120. That's a Heisenberg equation formula that you use it. So this is 120. So this is 120. And then your outer diameter. So outer diameter, we already know in mm I'm giving. So because on the brochure I have those details. So what is the value? 25 heavy is, we already got it right previously. 25 is 33.8, alva? 33.8.
Yes.
This is 33.8. Wall thickness is 4 Your ID is this one minus 2 times the wall thickness. Into wall thickness divided by 25.4. That will give me inches. Right? So this is in inches, right? Then I have to vary about the length of the pipe. So length of the pipe, in our case, the length of the pipe from here to here is what I have to calculate, which is 3,500 mm. So the length also should be in feet. So here we know the value is 3.5 meters. So that will become 3.5 into 3.28. So that will give me 11.48 feet. You agree?
Okay.
So now we have to calculate what is the pressure drop across. So for that we use the simple formula, which is your Heisenberg equation. We have it. P is equal to 4.52 into Q power 1.85. Just a sec. I'll keep this formula and we'll write it better. Zoom this up. Is equal to 4.5. Allows 4.52 into discharge, which is flow, power 1.87. Power 1.855 All right, divided by C power 1.85. C power 1.8 brackets for my ease. Uh, D8 alva. D8 power 1.85. 1.85 uh, into again I'll open the brackets, which is D power 4.87. D is your internal diameter, alva. So this one power 4.87. This will give me pressure drop per length. That after don't you think you have to multiply it with the length of that? So this whole thing, I'm just multiply it with the length into length in feet. So that will come to know the pressure drop is 1.02. Am I clear?
Yeah.
This is the value in PSI. So if you give this inputs, automatically I'll get the del P value. Understood?
Yeah.
Okay. So we came to know that the pressure drop across is 1.02 PSI. So from A to B, the pressure drop that I have is
0.02.
just a second. Pass the pen. Time. Just actually. Just a sec, guys. I'll go on mute for a minute. Please don't mind. Yeah. Sorry. Okay. Now you able to see the screen.
Yeah.
Hello. I'm audible.
Yes.
So here, the flow rate that we have here is what is the flow? Sorry, what is the pressure drop that we have got it, which is 1.02 psi. Psi is pressure drop. Pressure drop is equal to or del PL, right? Del P 1.02 psi. So here I came to know that the del P over here is 1.02. So don't you think at this location the pressure will be at this particular location automatically the pressure will become Q is equal to this pressure is 7.2 plus 1.02. So it automatically become as 8.22.
8 point. Yes.
So pressure at B is 8.22, right? So section, if I take B to C, if I'm not wrong, first I have to calculate what is the flow rate of B. So the pressure at this point is 8.22. Now, don't you think I can calculate the flow rate in this location?
Yeah.
So for that, we use a formula again, Q is equal to K root P here. So now what is the pressure I've got it here?
8.22.
8.22.
8.22. Say 8.22 if we give it. Sorry, here I have to give 8.22. 8.22. Automatically, the flow rate is 16.055 GPM. So GPM is 16.055 GPM.
These flow rates are in the header line, right?
Uh, no, this
Does it?
flow rate is at that sprinkler.
Where is it?
See,
Okay.
this piece of pipe will carry only water that is required for the sprinkler, alva.
Correct.
But whereas this piece of pipe, if you take it, section between B to C, it will carry about 16 plus 15.
So that's what I'm saying. This flow rate is for the pipe, not for the sprinkler.
No, this 15.02 is for sprinkler A.
Okay.
16.05 is for sprinkler B. The pipe section B to C, if you consider, say for example, you wanted to understand what is the flow rate in this piece of pipe. So in this piece of pipe, the summation of these two, alva.
Okay.
So it's 15 plus 16. So how much it will become? 15 to 30, 31. 31 point into 0.7 or something. You agree?
So means to say, based on the pressure, every sprinkler will have different flow rate. Is it correct now?
Obviously.
Based on the
That is
pressure
the
only.
reason we do this hydraulic calculation. According to this, you might have to select the pump.
Okay. Okay.
Understood?
Okay.
Okay. So like this, we have to do till this corner. So is it fine? Tomorrow we'll continue on this.
Yeah, yeah, no problem. No problem. But Chaitanya,
Anyway, for
one more
tomorrow
thing.
again, I'll try to connect by this 5, like by 5:30 in the morning. Number
Chaitanya,
one. Yes, you were telling something, Madhu?
yeah, yeah, yeah. Oh, just one doubt is there.
Sure.
See, when you take any building, no, like there'll be so much of sprinklers. Is this the way that every consultant has to do this design, or how is it? Generally, what
See,
happens? Practice, general practice.
general practice is not this. General practice is basically, see, though you have how much our area, we are doing it only for this section.
Correct. Yeah.
So, yes, if your area of protection is greater than 5,000 square meters, it's mandatory to do hydraulic calculation as per IS code.
Okay.
But as per this one, what do you call NFPA, whatever area is there, this method is mandatory.
Okay.
Yeah, or many people what they do is what is the minimum flow rate required, multiplied by the total area of protection, you will get the rough estimate of the water flow. That's like saying 15 GPM into the total area.
But either way, it's always good to do this. No, this does not take much time. When you have all
Yeah,
the
it will not take
format,
much time. No, it
okay.
will not take much time.
So it's a good practice that even if they ask or don't ask for the project betterment, better we do this calculation. Correct, no?
Yes, yes, yes.
Yeah,
The
yeah.
only thing is, the main thing why many people don't do or probably avoid doing also, because I've seen few consultants who probably might not know it also, but rare, because
Yeah,
most of the
yeah.
guys knows this obviously. So why they do it is no one gonna test whether this particular one unless client asks
Yes, true, true.
hydraulic
Now
calculation.
we have seen this. We have seen this at our office also. People say it will be done by the vendor. They don't do. That's what I was.
Okay, but vendor also, when a consultant doesn't do, how do you expect a vendor to do it in the first
Ah,
place?
no, I'm
It is
not against.
stupid.
I am against to that. That's what I wanted to ask you. But as a
Yeah, no, no, I
consultant, we
would
must
always
do
ask.
this.
In fact, I mean, currently, as I've told you, I'm working, right? So at this point also, if some consultant, when we have a consultant, I'll ask the consultant itself to prove that the numbers are right. So they'll share me all the hydraulic, even for plumb selection in plumbing also, I'll ask them the, calculation sheets,
Okay,
without
okay,
which I'll not accept their drawings.
okay, okay. Good, good.
Okay, so we'll continue from tomorrow again.
We'll try to start by 5:30 only, Chaitanya.
Yeah, yeah, we'll do it. No, no. Yesterday I was awake
No, no,
till
no, no, no problem, no
1:30 or
problem.
2.
No, in fact, yesterday even I was traveling Chennai. I was wanted to cancel the class. Somehow you only did it actually.
Oh, okay. Oh, yesterday as well, is it? No,
Yeah,
day
yeah.
before yesterday also I was working till 1:32, so that's the reason I
No, you
didn't.
see, in that case, you can take a break. No problem. No need to stress yourself again. Get
No,
ready and
no.
all.
See, two
No
days
issues.
continuously. I don't want to deviate. Give a break as well. That's the reason.
Okay,
And
okay.
also, what about plans on this Saturday? You guys are free. It's a holiday for you. How? I guess
Yeah,
design
it's
is
holiday
free,
for
right?
us.
Okay, because for me, it's not every. Just I stop the recording.